Another draft physics video presentation. Comments on comments and other things, of course. We'll get to AB science shortly. And just what kinds of duplicitous con artists they really are, these things called physicists. Just bishops and preachers and whatnot. Devotees of a pile of shit that they've invested in. It's their shit. And the truth just doesn't matter to them. They have their truth. But there's examples of this all over the place. These flat earthers occasionally show up here. And, you're just despicable human beings. I mean, I would actually, if I was running a government, I would use stuff like flat earth and other conspiracy theories as a way of winnowing you out of the population, of finding out, well, who are the lyingest scum, okay, and let's find them. Let's put them in a camp or something, let's give them what they deserve. Because you're not this stupid. You're a fucking liar, okay, because the evidence has been presented over and over again. It's irrefutable. Your argument is insane and silly. It's worse than religion, okay? It's absolute rubbish as a theory. It's 17 plus whatever W equals frog pie. I mean, it doesn't make any sense. It's just out of bounds. Out of bounds, that's the word for it. And you're a threat. You've got to be a threat to human beings. You've got to be eating your own poo to be stupid enough to be a flat earther. I mean, you have to be eating your own poo. Or you're incredibly dishonest. Like I said, there's no choice here. So, you suck. Either way. Either way, you're not robot functioning properly, and you belong, in the repair shop. Or, pushed off a cliff. It doesn't matter to me, frankly. I see no point in fixing broken toasters. No. Just throw them on the ash heap. Recycle them, into daisies or something. Something that can make sense. Anyway, so fuck off. If you're a flat earther, just fuck off. Okay? You got no chances here. You're not going to persuade me. Fuck off. Alright, anyway. So then this other asshole, I'm going to call you an asshole, I don't care who you are. This unannotated link shit is just so fucking annoying. If you're going to post a fucking link, then say, this is a response video, or say something, okay? Just posting links is horse shit. Alright, so it's a link to Lesage Gravity, which, the website, I have read it occasionally. It has, it has progressed. If anybody remembers 10 years ago, it was 3 paragraphs, right? I mean, it was a nothing web page, the Wikipedia page on Lesage Gravity. And now it's, miles long. Lots and lots of references on it. It doesn't have the whole story yet right, but it's got a lot of story. And the fact is, lots of arguments, and, at least some, obviously the counter arguments aren't being given fair view. But the point is look, it's already a proven fact, okay? The whole history of this channel is a proven fact that I'm not defending Lesage Gravity or Fadio's gravity or anybody else's gravity. I watched the 2 slit experiment and said, well, they're particles for sure. And then I speculated, well, what if all these other forces were also particles and we just can't see them? You can't detect them because we don't have the right tuner to tune in the gravity. Just like it took Hertz 7 years to find the other frequencies, right? They knew, Maxwell basically demonstrated that mathematically they probably exist. It took Hertz 7 years to find them, okay? So yeah, what if all this other stuff is the same kind of crap, okay, that's causing all these other effects? We just can't detect it. We don't have detectors for it. We can detect gravity the obvious way, okay, but yeah, we can't manipulate the force because we can't apply a force to a force and bend it or manipulate it, except in Einstein's little fantasy about the single photon being bent twice as much by gravity, right? The only aberration from the theory. The only aberration from all the experimental evidence ever collected is this stupid Eddington experiment that's never been successfully repeated, right? Alright, anyway. So don't be posting this crap. I mean, what's your point? I'm not arguing a 300-year-old theory, okay? I worked on mine. I know what electrons and protons. See, unlike these poor fellows from the past, they didn't have the information we have. You know, as Newton says, we stand on the shoulders of, I don't know if it's giants, but we stand on things' shoulders. We stand on the corpses of the dead people who did some work. And that's a fact. We see more. We have a much better view. All right, and with my much better view, I was able to eliminate all these complexities because I know that there's electrons and protons inside of Adam's asshole. Okay, so anyway, so this is just, the tangle of bullshit from you people is just so obnoxious. This whole conversation, the AB Science doing this video on mechanical gravity, was caused by a commenter of mine, by one of you assholes, who decided I offended you. Oh, it's deeply. And so he ran over to his channel and paid him money, okay, and suggested a video on mechanical gravity, right? Because although he didn't want to agree with me on the double slit experiment, he did see, well, there's probably some value in this gravity theory, this mechanical gravity theory, and he wanted a dissection of it, not a redundant, oh, I'll just read the Wikipedia page. I'm sure that's not what he was paying him for. I'm sure that's not exactly what he was after. He was after him dealing with the argument, and he won't do that. Well, anyway, so I thought of another simple way to analogize this. So let me do that, okay? I'll make it even a kindergartner can get it, right? I'm sure even a little kid could understand this. It's going to be so fucking simple for you retards. All right, and let's see if you can pervert it and screw it up somehow. Because that's all you guys, that's all you people are just, I'm sorry. I mean, the fact is the YouTube audience is 99% fucking moron. Arrogant, obnoxious, talk shitty, bold. I have a big giant dick. I got a big giant brain. I mean, even your names, just scream how preposterous your self-image is. Ugh. YouTube's just littered with these folk. Alright, so imagine, okay, if you will, the universe, let's start with just little bulldozers, okay? They're just little bulldozers. You just draw a simple bulldozer that way, and they're bulldozers, and they're just bulldozing along. I'm a bulldozer, I just bulldoze, right? And when the bulldozers hit each other, right, so the whole universe is just bulldozers, bulldozer, bulldozer, and they just can't stop going. Okay, they just can't. They can't run out of gas. They got nuclear power, whatever you want to say. They got super nuclear, whatever. They just don't stop. And when one hits the bulldozer, it just flips over. The little top flips over to this side, and now it goes that way. All right, that's all. So that's what the universe is full of. Now, if the universe was full of that, it would be pretty uninteresting because the way the bulldozers flip and all the thing, nothing happens. There's nothing, nothing can ever change. Nothing, whether they hit each other, don't hit each other, it doesn't make any difference. There's no use of any kind of energy or anything. So they're all traveling the speed of light, by the way. So they're all moving the speed of light. All right, now all I have to do, now I just stick some boulders in here and they roll, okay? So now the bulldozers, okay, can hit a boulder. And when a bulldozer hits a boulder, okay, something different happens, okay? Instead of going the speed of light, right, because now it's got to push a boulder, right? The boulder rolls much slower, so it's something much less than the speed of light. It doesn't even have to be much less. It just has to be a little tiny bit less. But anyway, it's less than the speed of light, and it rolls the boulder. And the same thing happens, though. If another bulldozer hits the boulder, right, this one's coming right for it, so to speak. So now the boulder's here. This bulldozer hits. Well, this one flips, This one flips, flip, and the boulder stops rolling because nobody's pushing it right now, right? So you've got to wait for another bulldozer to hit it to roll the boulder. But anyway, the boulder moved from here to here, and what else happened? Well, nothing happened here. This exchange was at the speed of light, no change in speed. But obviously this guy, through the whole period he was moving the boulder, he was going less than the speed of light, which means in the universe, he should have been here, okay? If it wasn't for the damn boulder, he would be here, not here, right? I mean, this isn't hard to figure out, right? So he has lost some velocity. His momentum has actually been reduced in the universe because he doesn't travel the same distance. So if I was to take his lifetime, right? So let's say he hits boulders, I could take his lifetime distance that he travels, and I could say, okay, there's the distance he travels. It's a line that would be, let's say, this long if there was no boulders. But because of the boulders, the line's only this long. All right. So you can see that clearly, there's a difference in the length of that line in the same amount of time, and therefore you have to say less momentum. So the places in the universe where there's boulders, energy goes in, that is, bulldozer goes in, okay? And the truth is, fewer bulldozer comes out, because of this delay, because of this, the fact that they're slowed down in here, less of them are always coming out. So more go in, less come out. Just the way it has to happen, because they're delayed. They're constantly delayed. The delay is perpetual. They're always 5 minutes late. No matter what happens, you can't stop it from being 5 minutes late. And so basically, that's the source of gravity, is the fact that more energy goes in than actually comes out, because you've taken some of the momentum out of this force. So any place there are matter, electrons and protons, the force gets slowed down. It's not really slowed down, right? When the bulldozer is slowing down when it's pushing the boulder, but you're still doing the same work, right? And that's the trick to it, right? You can sort of understand that if one bulldozer pushes it over here, the matter bit, and then the other bulldozer pushes it this way, they haven't accomplished anything with their work. They've just used time. They've wasted some time just doing this back and forth thing, and they haven't done any motion in the universe. And so they have less energy. Less energy exists. So the fact is that matter objects, although they look hot, they're actually cold because they're consuming energy to be hot. And that's why the Earth is molten in the middle, by the way, is because of gravity. Okay, the pressure that gravity's pushing in with is greater than the energy coming out. And that's why the middle of the Earth is hot. And so it explains what gravity is, why it exists. Yes, it basically says, well, energy isn't totally conserved because you have to use energy to move boulders. And moving boulders can mean something to us as complex objects, but obviously from our universe's perspective, it doesn't really care whether the boulders here or here. It doesn't mean much to the universe. But the fact is to do that, okay, bulldozers have to do work. And when the bulldozers do work, the force, there's less force in the universe. Just a fact. Bulldozer can't dig up, its tread can't run on as much earth if it's got to push boulders. If it's pushing boulders, there's less tread marks in the universe. That's the simple way to understand it. So you have, in a sense, destroyed some energy. You've used it up to move boulders around. There. Solved. The whole thing's solved. Right? All of the objections solved. All the objections having to do with some thermodynamic problem. There is no such problem. So that's what a modern human with modern information can do. And they're just pretending that nobody's had a new idea in 300 years, and nobody can understand concepts like these concepts better, because we do understand that there are electrons and protons, and that these things there's phenomena like charge and all that stuff. Wrong one. So, but the critics won't show up to argue an actual theory. Again, they'll just pick on the dead people. They won't pick on the living ones. Okay, like Ken Wheeler, they're cowards, pathetic cowards, and this is demonstrated by the fact that AB Science has now blocked me. Okay, so all I did is ask a simple question, basically. I mean, yeah, it was a little bit, how far does the average beta particle, electron produced by decay, travel in a vacuum? Now, they can't answer the question because apparently this experiment isn't done. It seems so obvious to me that, you can see electrons in cloud chambers, and you can see they just run out of gas. They don't go very far. And you can make an electron gun, and you can see the electrons don't go very far. So there's lots of things you can do to see that electrons don't go very far. But what would they do in a vacuum? How far can they travel when naturally stimulated by a radioactive event? When pushed by natural radiation, how far do they actually go if they were free to go as far as they could in a vacuum? And we're to believe, no, never done. That even out in space, they couldn't just sit there and when they had the doors open, and they're floating around in space in their little space suits. One astronaut could stand over here, and one could, float. And one could float over here, and one could have a little electron gun, and one could have a little gun a little electron receiver, and they could see if they could shoot some electrons to each other. No. Nobody was curious enough. Anyway, can you cite any experimental evidence showing electrons don't experience drag? So the simple argument is, it seems quite obvious to me that there's something fundamentally different between helium nucleuses, which they do concede travel billions of miles through space and crash into the Earth, and the fact that protons and electrons don't do that. The only electrons we get are like from the sun, but they're in a plasma. That means there's a bunch of atoms coming off the sun, a bunch of ionized gases, and those ionized gases produce electrons. Okay, but it's not electrons going from the sun to us. That isn't happening. They're getting there by being part of atoms. It's a real issue, a real question, a real counter argument to this dismissal that, drag means it can't be possible. Well, what if drag is a real thing? Yeah. Then I guess it's possible again, right? So anyway, I made comments responding in the last video. You saw I made response comments. He deleted my response comments. So he's basically closed this thread without saying he closed it. Okay, so he isn't informing people that, yes, counter arguments were made to these points, but we're not going to let you see them. Okay, and so we're going to pretend they were unresponded to, and that he could make his little assertions here and they're going to stand because nobody made a counter argument. Well, somebody did make a counter argument and he deleted it. All right, so he might as well just delete the whole thread. If he's going to shut me up in the middle of the conversation, then the only honorable thing to do is just delete the whole fucking slop and say I'm a coward, because that's what he is. He can post comments on my videos. He called me ignorant. All right, he said my theories are dumber than dumb. Okay, these are quotes from him on my message board. I haven't blocked him, right? So he can be rude as fuck, and that's okay, because they're used to it, okay? That's what they're used to doing. They're just used to mocking retards. That's what they do on the internet, okay? They don't really want to have their physics challenged the same way. They don't want to be treated the same way. They don't want to be subjected to the same trial. They don't want to be put on display and mocked and pilloried. They're just fucking hypocrites. Despicable hypocrites. Alright, so we haven't even gotten to his video yet. So I'm going to play his whole video, just because it just shows what pompous, arrogant douchebags these people are, and it just verifies the point. And they clearly have no willingness. Look, I mean, even Newton's got some great quotes, like the standing on, giants. That's his quote. He's got a quote about. He has a quote about gravity, right? About only an imbecile would think it's being caused by nothing. I can't remember the exact words, but that's basically you'd have to be unreasonable to think the cause doesn't exist. Just because I can't articulate a cause, it would be silly of you to think there's no cause. But I wonder what he would say about bent space as a cause. Again, I could just analogize it to light bulbs. If light bulbs actually did work without electricity going in, you'd be pretty hard pressed, right, to come up with an explanation. And so you might be vulnerable to saying something silly like, well, the ether is sucking, etherites out of the light bulb. So you'd come up with some explanation that just, it's not a real thing. It's just a gremlin theory. And that's all bent space is. It doesn't answer the question, what is gravity? We already know what gravity is. The inverse square law. And all bent space is saying, well, I can draw the inverse square law as a gravity well. So should I draw a light bulb as as a light bulb mountain? Should I just say that somehow the light creates a mountain and the mountain shoots into the universe? I mean, it's just too silly. Anyway. All right, so so Cato the Wiser, douchebag, horrible, evil, just a terrible person. Anyway, in talking about these people who accused me of all kinds of hate crimes, this guy's an overt anti-Semite. I mean, he types the shit in his comments, okay? And it's okay to have him on your comment board, though. So you'll sit there and try to imply that I'm somehow a despicable character, but you won't do it to this asshole. So we'll read these comments on his board too. We'll point out what dumbasses these are. That the internet's just covered in dumbass, especially on science channels. I mean, dumb, silly little. I mean, oh, I'm so glad you love Jesus like I do. They're just disgustingly religious. Anyway. So what would be the easiest way to test that? So we want to test whether electrons are dragged. Okay, well, I sort of pointed out the easiest way is just to put a little bit of radioactive crap in a bell jar, and then outside the jar see if you can detect any of these electrons. Or inside the jar at a distance. See if you can detect electrons from 10 inches away, and then try 20. That would be it. The linear accelerators would be a long vacuum tube. Well, I've already done a video on linear accelerators, so this is again part of the whole fraud of all of this crap. People have these dopey impressions about how things work, and they don't work how you think they work at all. Okay, a linear accelerator isn't just a big tube. No, it actually accelerates through the entire tube. Okay, the entire tube is an accelerator. So it's constantly producing radiation. And it's producing so much radiation that they have to have a foot wall of lead, between them and the receiving thing. Just because if there's so much radiation being produced by the accelerator is producing so many X-rays and gamma rays and all that other kind of crap that, the person would be eviscerated by all of these, all of this force that the gun is also producing. So the gun produces some electrons, but it also produces a ton of other stuff. Which brings me to cyclotrons, which are another joke. Because they say cyclotrons are accelerating protons and electrons. No, they're not. They're accelerating ions. So it's, again, they can never tell the truth. See, they just basically say, well, because an ion has an electron in it, it's accelerating the electron. Oh, no, it isn't. It's accelerating ions. It's accelerating atoms. So again, we're back to this plasma argument. People, they apparently don't really understand when they're moving a plasma and when they're moving actual electrons and protons. They don't make distinctions between these things. They're scientists, yet they can't figure out that these are different things. I really shouldn't have to explain this linear accelerator stuff, but I'll throw it in as a bonus quickly. Because it's like I said, it's a good point to raise, okay? Is that people have this perception that, okay, a linear accelerator, obviously it's linear, okay? It's just a long tube, okay? And you got a little receiver down here that you're going to see if it has a charge on it. All right. Now the joke of the whole thing is when they're accelerating and they say, okay, we're going to increase it to 50,000 million electron volts, right? They're going to increase the voltage. That is the differential between the minus and the plus that they're using to accelerate with. And then they're supposing they're making the particle move faster by doing that. And the funny thing is they go from measuring the charge. See, if you want to measure electrons, what you do is you say you have a plate that doesn't have a charge on it. You take the charge off. It's not decidedly negative or decidedly positive. It's ground, right? Okay, and you take that plate and you separate it from ground. So you disconnect the ground, and now you see if you can get charge to build up on it. Then you know you're getting electrons. So if electrons are hitting the plate, they're going to stick to the plate and they're going to create charge. And the plate's going to become negative because you're collecting electrons. So that's how they start off here. So when they start off with little acceleration and they start collecting electrons, they're measuring the charge. And then what happens later when they're going faster and faster? They're not measuring charge anymore. They're measuring heat. Okay, they measure how hot it gets. Well, guess what? The X-rays and the all the ultraviolet light, that stuff causes things to get hot, right? If I pump a bunch of that crap at anything, it's going to get hot. So now I'm not really measuring electrons anymore. I'm just measuring how much crap, how many rays of energy I'm shooting at the target. Electrons are irrelevant now. Anyway, but so to understand, so they have a little heated element, okay, producing all kinds of crap. Ions are flying off of it, electrons, protons, whatever you want. It's a mixed bag. Heat causes destruction of the atoms. The atoms are falling apart. There's little pieces of atom falling off because you're ionizing the surface and it's breaking down. All right, so that creates some loose bits. And then you sit there and you put a charge across here, okay? And so all the negative charge bits will go to the positive. So you can create a positive potential over here, and they jump that direction. Well, they're moving pretty fast, and so then you fool them. They move, you put some holes in for them to go through. Some of them go through the holes and miss hitting the plates. And now you fool them by putting another charge in. And so now they're jumping to this new charge. And then they'll jump to a new charge and jump to a new charge. So it's a bunch of stages of acceleration. It's not just a tube and they just let the electron fly to the target. No, there's accelerator 1, accelerator 2, accelerator 3. They accelerate it more than once in this linear accelerator. And like I said, by the time they really get this thing moving, they're not even measuring charge anymore. They're measuring heat. And you don't know what's causing the heat. I mean, like I said, ions will create heat. You throw ions at something, atoms. That's going to cause it to get hot. You throw any kind of radiation at something, it's going to cause it to get hot. So now you're not just measuring electrons anymore. Anyway, yeah, so that's enough of that. So anyway, none of these arguments will be dealt with, obviously, because he's run away from the conversation. Surely it wouldn't be a perfect vacuum. So this is even the sillier part, right? I mean, this isn't that complicated. You're just going from this obviously a cloud chamber full of ammonia gas, something like that, full of gas, full of vapor. You could say, oh, the electron is plowing through a big, bunch of thick stuff, and that's why it's running out of fuel, is because it's got to go through all these thick atoms. Obviously, a vacuum would just be saying less of that. Whether it's a half vacuum, 100% vacuum, that isn't the difference. What you're trying to figure out is that there's some point where you really start to increase the distance the electrons can travel. Does it get dramatically, clearer, the space it's moving through? Obviously, if I throw a wrench in a underwater, the wrench doesn't go forever, right? Okay, if I throw a wrench in atmosphere, it doesn't go forever. It only goes forever in space. So the better the vacuum, yes, the further the wrench should go. And that we're just trying to find a vacuum that's good enough to say what's stopping the electron now. Okay. And we're talking about an experiment with more than one electron. Obviously, the odds of all the electrons hitting something would be, infinitesimally small. So there should always be some electrons that just happen to be on the lucky road that doesn't have any potholes in it. So you should be able to receive some of them at increasingly huge distances. And we don't have any evidence of that. All right. But the effects of some remaining air can be accounted for, ? So again, I don't know why this is even an issue. We all know that if I take a bell jar and I start taking the air out, the bell gets softer and softer, and then finally I can't hear it. Okay? And that's all we're looking for, is the change. How dramatic is the change? An electron hitting even one atom is going to impede it. Yes, but the fact is, if I'm throwing a whole bunch of electrons, I have real laws of probability that say, 10% of them are going to go pretty far. Don't know if fields can be negated. Well, they can be in the sense that as long as you know the experiment's taking place within a certain amount of time and all that kind of stuff. I mean, obviously gravity's not going to be significant over 10 meters. I'm just looking to see if they can actually shoot an electron 10 friggin' meters. Can they actually accomplish even that? And I'm saying the truth is it's doubtful. Yeah. Um, without the implication that what are they moving and how did they move it. Um, See, part of the problem with not having a vacuum is that you're shooting a bunch of other energy, right? You're shooting gamma rays and ultraviolet light and all kinds of high frequency energy is getting shot when you're heating this element. And so all of that energy is flying through the space, and it could hit an electron 3/4 of the way down the tube. It could hit an atom and break off an electron. So you didn't shoot that electron across the whole tube. You hit an atom that was almost near the detector and shot that into it. You know what I mean? So this is where it all kind of falls apart. And the truth is these detectors, again, they're not perfect. So how can they tell? They will react. Like if you have something that's even just going to be charged, we already know that ultraviolet light will charge surfaces. So I mean, it's we already got a problem. How can you tell whether it was a high frequency bit of radiation that charged the surface, X-rays, or whether it was charged by an actual electron? So the whole thing has huge limitations as when you really want to tease out these truths. And again, all of these experiments, you're relying on their testimony about what the experiment does. And I just keep pointing out to you, look at the double slit experiment. It couldn't be any simpler, just holes in a material. And they can't describe that accurately. So if they can't get the simplest experiments, if they can't honestly report the results of the simplest experiments, why do you trust them on any of these other experiments? You see, I've already pointed it out. I mean, I've already illustrated the two-slit experiment is simply understood. There's nothing all that complicated about it at all, and it's much simpler than their mathematics even implies. You don't have to do all this sine theta crap. It's how many wavelengths of difference there are will tell you exactly how many places there can possibly be phase or out of phase. It's already decided by the slit width. Anyway. They don't have to interact in space. So that's it. Like I said, so he shut down the whole conversation and, just showed that I'm exactly right to call these people evil and douchebags and hypocrites, and that they are just pulling this is all just a sham. This idea that they give a shit about the truth or they give a shit about science. So anyways, back to Newton's quotes. Yeah, Newton had a quote about the whole problem of disagreement with people. And say, I'm sorry, I should remember the exact quote, but it's just this whole idea of temperament, and implying it's difficult, and but there's ways around it. And look at the problems Newton had. Newton had the same problem with people saying he stole ideas, or people saying all kinds of crap. So there's no winning here. There's no way to have an argument without there being some thermal agitation. Okay, so some whatever emotional waste. That's the nature of being human. But they're just hypocrites about how they deal with that. They can be emotional, but you can't. You can react. They can react to you, but you can't react to them. They can insult you all they like, but you can't insult them at all. I mean, it's just such hypocrisy. Alright, so maybe we'll get on to the video, and then we'll do the comments, and do 3 or 4 videos out of this crap. Alright, so he first lies by not even telling the truth, right, about where this idea came from, why it was brought up, how it was brought up. So one of my subscribers got pissed off because I insulted them in some way, because I said their argument sucked or whatever I said, and they decided to get back at me. Okay, they would go finance this asshole and give him money. Okay, so yeah, that's a great counter argument. You defended yourself so well by doing that. Alright, so to get back at me, he gave this asshole money. So now the asshole pays attention to his comments. And so the asshole asked him, well, what about mechanical theories of gravity? Because even though the asshole knows, well, the asshole already knows that I'm making valid arguments and somebody should address them. And so I guess he thought that somehow AB Science was going to have enough integrity to do that. But no, so I'm just saying, I double proved you, the asshole that I called you, because look at what the mess you made. You've now financed an asshole who's dodging the very question you attempted to finance. So, you weren't very successful. You weren't very productive, all right, in your counter argument. Yeah, because all you did was finance the very thing I think you were trying to evade, which is these closed-minded assholes. All right, anyway. So that's how this started. And so the whole point is AB Science was clearly knew this is relevant to my theory, this conversation. Clearly the subscriber, it was relevant because of me, and yet he doesn't address a single one of my points on the subject. I mean, what a weasel.
Someone asked me to look into...
So it wasn't just a someone, right? It was one of my ex-subscribers. Okay, not just a someone.
A topic called mechanical gravity.
Yes, that was a kind of a funny term, right? But I found it on the Wikipedia page. I did see that term, but I never heard it called mechanical gravity. Everything should be mechanical, right? I mean, it's physics, for fuck's sake. Shouldn't it all be mechanical, god damn it? Unless you're religious. I mean, unless you're religious, doesn't it have to be mechanical? Is there something in evolution that's not mechanical? Now, they don't say a mechanical theory of biology. Nobody has to say that, do they? No, I never heard anybody. I never saw Dawkins or anybody saying, oh yes, well the important fact is that this is a mechanical theory of evolution. I mean, nobody has to say it because, yeah, of course it's mechanical. Fuck. The answer should always be mechanical because otherwise the answer has to be something silly like Gremlins did it.
Had a quick look into this and it sure seems to be rather interesting.
Oh, yeah, he had a quick look and it was interesting. Yeah. So again, the whole context is based on the fact that I'm the one making it interesting now. Because I'm defending it in modern terms, okay? So now it's not just 300-year-old arguments you have to deal with. You have to deal with a modern argument. And instead of dealing with it, even though I'm offering more legitimate YouTube channels $1,500, and I have asked you how much I have to pay you, and you have refused to give me an answer, okay? You're playing your little game, okay? What's the point? How much money do I have to pay you to address the arguments that have been made? Do a two-slit video so I can rag the fuck on it, right? I mean, he defends this physics, and yet I've overtly told him, go ahead and make the video then. Go make the video on the two-slit experiment claiming you're going to do it accurately, that you're going to do it factually, all right? And I'll decimate it. I'll point out how full of shit you are.
In a nutshell, mechanical gravity refers to a set of ideas that were being developed in the time between Newton and Einstein.
No, they were probably being developed since mankind threw a rock in the air and the rock goes up and hits me in the head. Hey, fuck. You know, I mean, this idea of push-pull, I'm sure there was some cavemen who were thinking about that and probably just contemplating, hey, you know what? There's only this one kind of concept, push. And pull, yeah, it's not simple at all. Push is happening everywhere. Everywhere something's getting pushed into something else. But pulling, that's fucked up.
Famously, Isaac Newton derived his law of universal gravitation based on observations of the moons around Jupiter, to which...
I don't know why that's ironic or whatever he said, but anyway.
He applied his laws of motion. Now Newton talked...
Right, so they're just laws of motion, but the real important thing was just the inverse square law. That's the whole game, okay? The entire theory of gravity is just this simple recognition that, oh, it's doing the same thing as a light bulb, except it's in reverse. So it's exactly the same distribution of energy as a light bulb, and it follows the same rule as this hand, right? 4 times bigger, half the distance, 4 times bigger. So that's the real argument here, is this has something to do with, as things travel through space, there seems to be this idea that the distance between them is increasing in 2 dimensions. The square. Yeah.
About how he did not know what the mechanism for gravity is, and this is why his...
But he did say, on top of that statement, he said, but if your theory is magic, that's probably not right. God doesn't waste his time pushing planets around, right? Newton was a religious nut, and he was sort of implying that, well, if you think God's doing it, well, he's probably got better things to do, so he probably has some mechanism in place that takes care of that for him. He doesn't have to do it. He doesn't have to put the water into the clouds, right? There's a mechanism to put the water in the clouds. So he doesn't have to do it for us. He doesn't have to make it happen because there's a mechanism that's making it happen. And Newton was pretty clear on that. And I'm sure Newton would have said, what the fuck, if you suggested, well, space is bent. See, the nothing that's, all that black stuff, it's really bent in 3 dimensions. Kind of, well, maybe. No, Newton would have said, you're going to give me a 2-dimensional model and say it has some sort of relevance to what's happening to the spheres in space? No, you can't do that. That's no good. We could throw that in the garbage.
Framework is called Newton's law of gravitation, and not...
Again, it's not Newton's law, it is the inverse square law, so that's all it is. That's all that matters here. That's the only relevant thing. The big discovery was it's an inverse square relationship. That is, the gravity gets weaker and weaker the further away it goes at an accelerated, in 2 directions, which means 4 times the weakening.
Newton's theory of gravitation. Of course, after Newton presented his conclusions, there was a scramble to find a mechanism behind the law. No one ever really came to an agreement, and the
right, because it's invisible force, okay, and it has this, like I said, the quality of it is very strange gravity, because there's no obvious, unlike the light bulb, unlike the lamp, the candle burns down, things happen. We can see systems that have energy in them, and we can understand where the energy came from. Gravity doesn't make it obvious, because the fact is you're sitting there saying, well, yeah, exactly, I can create a theory where the energy comes from the outside and it's pushing things in. And that's the only one that makes any sense, but then I have to explain, well, where did the energy come from the outside? And now you have to make suppositions about how the whole universe is shaped and formed. And those speculations are obviously not going to be based on some experimental evidence. You can't go back in time and play the videotape.
The subject provides a great who's who of famous scientists throughout history being very wrong about things.
So again, to say they've been very wrong about things, I think their analysis was very good. Most of them, they sat there and had to deal with a bunch of these thermal arguments and ideas about how you're saying things interact. Now, if you say that, again, all you have to do is change the rules in the bulldozer example, okay? And so the rule is the bulldozer never slows down. It puts it in high gear and moves the boulder exactly at the speed of light. Well, if that happens, well, then there's no destruction of the bulldozer's energy in the universe, and therefore there's no diminishment of it, or how we want to describe it. It moves just as far. And so then you don't have any gravity. So you make a subtle change to a rule and it has a big impact.
So
again, 2 plus 2 plus 2 physics is what I'm arguing. 2 kinds of force, 2 kinds of matter, electrons and protons, and 2 kinds of interactions. That's it. That's all you need.
Explore these ideas a bit further, because this gives an opportunity to shit on some of the greatest minds in history rather than just flat earthers, woo peddlers, and climate change deniers.
Right, anybody who makes an argument against you, and again, all they do is pick on the worst case. Okay, they find the biggest imbecile. So it's just like the news goes out and finds the big. What did the biggest asshole on earth do today? Okay, that's news. No, the real news is how are we going to pay the debt? That's the real news story. Is hey, there's $8 trillion in the Federal Reserve. How are we going to pay that back?
I think the best place to start is actually before Newton with the concept of ether vortices as proposed by René Descartes.
I don't know why we would even mess with something called an ether vortice. That doesn't sound mechanical to me.
In his book The World, which he wrote between 1629 and 1633, but not published until much later because of a fear that the church would consider it heresy, and his buddy Galileo already got into a tight spot with the church at this point. The treatise is an interesting one, as it does speculate on the idea that everything is made of small particles and heat is actually just the motion of these particles.
Just a minute, please. Alright, I think I'm back. So anyway, this just, ether theories are, in my opinion, always fail because these are wave theories. Waves don't travel in straight lines. It's all over the place. It just makes a mess. As Ken Wheeler says, it's all curvilinear. No, the universe is made out of straight line forces. That's what Maxwell's equations show. That's what all of the charge theories, they all demonstrate, is you can just draw the straight lines to measure exactly what the force will be. You just measure straight lines from point A to point B, and you say how many lines are there, how long are they, how thick are they, and that's all you need to know. And you'll know exactly where something's going to go because it's all based on straight lines. The curved path of the moon is made out of a bunch of straight lines.
But he also speculates that everything is made of three elements: fire, air, and earth. Whatever happened to water,
Well, why do we even waste our time with that? But water would be made out of earth. I guess that's what he meant by earth. There's no such thing as a clump of, what's earth? So earth is, unless you're saying that, earth means dirt. No, I guess earth means material stuff.
No. Descartes also described the three laws of Cartesian motion, and the first...
and Benjamin Franklin and, the inventors of electricity talked about it like a fluid at first. So you're going to mock that too?
Law states that each particular part of matter always continues in the same state unless collision with others forces it to change state.
So each particular part of matter. So again, this is this idea that somehow we're going to have one rule for every single piece of matter and say that every single thing is the same, when it just doesn't make any much sense to be saying something you can't defend because you just don't know what all the other little pieces of matter might be. But I mean, this is force law makes perfect sense to me, I'm saying, but obviously there is a subtle variations in how this force law can be applied. And again, understanding simple things like, do bulldozers slow down when they have to push a bunch of dirt? And the fact is they do.
The second law states that when one body pushes against another, it cannot give the second body any motion unless the first loses as much of its own motion at the same time.
So clearly the bulldozer is losing motion, okay, when it's pushing dirt. So again, the analogy doesn't break down in any sense. As long as you understand the bulldozer is supposed to be at somebody else's house at 3 o'clock. And it can't get to their house if it keeps getting slowed down by pushing dirt. So if it doesn't push dirt, it gets there at 3 o'clock. If it pushes dirt, it doesn't get there at 3 o'clock. Just a fact.
Finally, the third law states that when a body is moving, each of its parts individually tend to always continue moving along a straight line. Now,
so the universe is made out of that stuff. The straight line force thing makes sense everywhere. It explains the inverse square law. It explains what light bulbs are. Light bulbs are rays of light. This whole hand thing is happening because you're changing the angle vectors of the light that can get to you. How many vectors can get to you is being decided by how close the hand is, okay? Some of them are now invisible. You can't see some vectors as the hand gets closer and closer and closer. That's what it makes it's the straight line theory works really well in explaining everything.
It's cool because you can see that Descartes was exploring these conservation laws that are the foundation of Newton's laws, but Descartes was also insistent that the whole universe was filled with ether particles because a vacuum can't exist. The idea then is that if one particle moves...
Well, there'd be no point in showing the idea with a bunch of empty space between the particles, right? Because that would be empty space again. So I think they would have to be smashed into each other, wouldn't they? Wouldn't they have to be right next to each other? I mean, if you're going to say there's no such thing as space, that nature abhors a vacuum, or whatever you're going to say. Durr.
The empty space it leaves behind will instantly be filled by another particle, but of course that other particle leaves an empty space, which is then also filled by a third particle.
Right, so you have to have empty. So the point would be to smash all these little squares together, and then you have an empty space. Okay, then you put an empty space in there, and then you just have all the forever, everything's running to the empty spaces. Because there's no empty spaces. There can't be any empty spaces. So you shouldn't really illustrate it with a bunch of empty space in the diagram. You can't do the theory of no empty space by putting empty space in the theory.
He reasoned that this causes ether vortices, which are responsible for the orbits of the planets. He saw this kind of like a fast-flowing river going around a bend. If you drop a feather or some leaves in a river, then these would go around a bend quite easily, but a heavier object, like a boat, would be deflected a bit, but most likely hit the bank on the far side of the bend, as the force of the water is not sufficient to get the boat to change direction sufficiently to go round. In this analogy, Descartes sees the water particles as the ether particles swirling around.
Right, so, and the difference with bent spaces is the particles are just going into the center of the earth, and they just disappear from existence. So they just fly into the center constantly, constantly, constantly. Bent space means convergence. As Susskind says, an anti-divergence. Yes, anti-divergence means convergence. Okay, that's simple enough, right? All right. And so if it was to use this little two-dimensional diagram to show what does bent space look like, it would look like this exact thing, okay, except instead of swirling, they're going right into the center and they never are heard from again. Because it's magic.
And the planets as the heavy objects. This of course implies that objects with more mass must have larger orbital radii, and today we know that this is somewhat problematic. Now Huygens later developed this idea further such that it had an exact mathematical form. However, it did not follow the inverse square law, and Newton had already demonstrated at this time that the inverse square law is definitely a thing.
Alright, so he says it's definitely a thing. That's understating it, really. It's such a thing. It's defining the shape of the planets. It's defining everything about how the universe functions. This law is all over it.
Agreed that this was a failure in his model and attempted to update it, but unfortunately he ended up presupposing the universal law of gravitation, so from a mathematical and philosophical standpoint, it was useless.
Right, so Huygens was a clockmaker, frankly. But I mean, all these people are absolutely brilliant. There's just no, to be surmising all of this stuff out of so little information, by candlelight. I mean, come on. Amazing.
Another issue is that the ether vortex idea would lead to only circular orbits, and we know that planets' orbits are not circular.
Well, we also know that their velocity is unchanged, and it's not being created by swirly bits. That the velocity is something they come to the show with, so to speak.
Though we now know that the mass distribution doesn't work for the orbits in the solar system, at the time they couldn't know. The right bodies hadn't been discovered yet. But back then the big killer for this idea was that you could plainly see that there were objects which opposed the direction of the ether vortex and thus violating the laws of motion. Neither Descartes' version or Huygens' version were ever regarded as viable theories. But next is the concept of ether streams, and Newton himself entertained the notion of ether streams and that normal matter was carried by the ether streams.
Look, Faraday thought there was, gears. Atoms were gears, and the force was little, gears in between and mitigating the, Yeah, they're just trying to understand. So again, I don't know why. There's really no point in going back and saying what did they do or say. Just deal with the actual arguments, the actual mechanical facts. What can you mechanically draw? What mechanism is consistent with the observations? And that's all you have to do is say, can bulldozers explain? Yeah, they can. Can an analogistic model be made to work? I'd say the great failure of your gravity model is no energy. Where'd the energy come from? Your model for magnetism, where'd the energy come from? You're denying something quite obvious, which is the energy is in the universe, and that's where the momentum is. And that's how bodies have momentum, is because the universe gave it to them. The force out there gives the stuff in there energy.
Streams like in Descartes or Huygens framework, and it was carried towards massive objects. Newton took quite an interest in this idea, but he ended up settling for, no, fuck it, I don't know. It's
okay, well, that's kind of silly. He didn't settle for, he just was honest and said, yeah, there's nothing that works, okay, so far. And again, Newton has these liabilities. He couldn't understand that the sun was made out of hydrogen, or the gaseous planet was made out of much less dense atoms. I mean, that whole concept. So he kind of got fooled by size. And so, Newton did think, actually, that there was something going on, because these big bodies seem to have more of this gravity. Less proportionally. He even made an arguments like that about magnets, right? That small magnets are more magnetic than big magnets. Because he didn't fully understand that this stuff came with huge variations in density.
Probably magic. Now, Bernard Riemann picked this idea up again in 1853, where he assumed that the gravitational ether is an incompressible fluid and normal matter is an ether sink.
So there you go. That's exactly how they teach bent space. That's the model. That's bent space right there.
Where the ether is destroyed or absorbed. This causes a flow of ether towards matter and everything else.
Einstein admitted somewhere, there is a quote that, when push comes to shove, bent space is an ether theory. Yeah, well, you can't bend nothing. Einstein pointed, of course you can't bend nothing. It has to be made out of something.
Just rides that flow. However, this leads to a problem. If the ether is some medium like water that makes stuff move, it must have some energy so that it can transfer that energy to the object.
Yeah, that's right. So if you actually had to make bent space out of something material, out of something real, then all of a sudden it wouldn't work, because it'd have all kinds of thermodynamic issues. But because you made it out of gremlins, you don't have to feed gremlins. Gremlins don't need food. They don't leave poo behind. They don't scratch up the furniture. They don't do this. They don't do that. So gremlins are the perfect little answer. So yes, you're using a magic theory. And of course, yes, magic doesn't have implications.
Make it move. So if the ether is destroyed or absorbed, where does that energy go?
Yes, well, where does it go in bent space? Where does the magical bendy stuff go? Where does it go? You say you can convert matter, actual electrons and protons, into bent space, because that's what LIGO says. Solar masses are converted into not light, not X-rays, not Hawking radiation, not any kind of known radiation. No, it's actually converted into the bending of the space. How does it do that? Oh, there won't be any mechanism. It's not a mechanical thing, of course. It's God.
Riemann speculated a workaround by suggesting that the ether zaps off into another dimension or universe, but of course...
Yeah, yes, and your physicists are doing that all the time now. Your little magical multiverses or your 10 dimensions. All your fucking dimensions that don't obey the rules of dimension. So there's no real point in having words that actually describe something like wave or dimension, because none of these words have any consistent definition. We know that dimensions are supposed to be perpendicular to the existing dimensions. That to be a dimension, you actually have to figure out how you're perpendicular to the other dimensions that already exist. The ones that are already acknowledged to be a dimension, you have to somehow be perpendicular to all of them. And if you're not, you can't be a dimension. Yet they just invent new ones all the time.
Of course, this creates more problems than the theory solves. Okay, at this point, I can anticipate the electric universe nutters whining about the...
So again, he can call people nutters. He can insult people. It's all okay, right? Because those are the hypocrite rules. But nobody can say, oh, these fucking bent space nutters. Oh, no, you can't say that. I have to delete your comments. Even when you don't even say that, right? I didn't even say anything like that. And he deleted the comments.
Many worlds interpretation of quantum mechanics and call hypocrisy, as it uses multiple universes to explain stuff as well. Now, my response is simple. The many worlds interpretation is just speculation. It's not...
Oh, it's just speculation. Oh. And what's the difference between speculation and your proven theory? Oh, that's right, absolutely nothing. There's no distinction whatsoever. You've proven nothing with anything called real evidence. You've just innuendo. It seems like it's acting like a wave. It's behaving wavy-ish. Yeah, oh, that's real evidence.
Theory. Now, Ivan Yakovsky proposed that the ether might be converted into new matter rather than being absorbed or destroyed. But again, that still creates more problems than it solves.
Right, because matter ends up causing the very effect. Okay, matter is the thing that makes the universe change. And as soon as you pop matter in there, you're going to change something. It's more boulders for the bulldozers to roll.
This suggests that all objects will increase in mass over time. The idea of ether streams was then also never accepted as a viable theory. Going back in time to 1671, Robert Hooke proposed that...
Really no point. So this is Newton's time. So Hooke was Newton's adversary.
That all bodies actually pulsate in the ether, and that this causes ether.
Right, the jellyfish theory. So, you know, we have to come up with if it's happening on the inside and going out, instead of the pressure being on the outside going in, if you're causing the pressure on the inside, you have to have a pressure causer, which means you have to have something, you know, flapping its arms or doing so. So you have to have jellyfish at the center of everything. There has to be a little jellyfish going push, 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 push. Yeah. Too silly, right? That's too silly.
The waves. He argued that massive objects move towards the source of the wave. Now, about 200 years later, James Chalice picked this idea up, and he actually formulated a mathematical framework for this, which appeared to work, but it brought an interesting prediction. If the wavelength of the wave created by one object is large compared to the size of the other object, then there would be an attractive force.
So these are just the games they play. So this is like Einstein doing Mercury's precession. All you need to do is come up with some rule that only affects things that are very close, because your rule is basically saying, you know, it could be the inverse square law, or it could be the r cubed law, you know, or the r fourfold law, or some other law that means that it affects far away things not at all. And so then you can make something work because the context doesn't make any effect that causes anything else to be screwed up. And so that's what all this stuff, depending on a wavelength, would do, is just basically it's a gimmick. You know, it's just a way of saying, of allowing something to happen in one context and not having any implications in all the other contexts.
If the second object is larger than the wavelength, the bodies repel. And Chalice claimed that this could actually explain all forces. The question then becomes how large the wavelengths need to be. Now, two galaxies will be attracted to each other, so you could say that the wavelength needs to be larger than a galaxy, but then the wavelength is larger than pretty much anything, and it's always attractive. But then you could say that this is extreme and you only need to consider the constituent parts. And then you can take that down to a subatomic level even. And this is where it gets interesting again. Take a positron and an electron.
Yeah, it's like there is any such thing as a positron. Yeah. Dream on.
They would be attracted towards each other. Both are infinitely small particles, so you can't have a wavelength shorter than the width of an electron or a positron.
Well, you know that this has nothing to do with charged objects. It's completely not applicable. He knows that charge is 10 to the 40th stronger a force than gravity, so obviously any effects of gravity would be minimal. And the whole point would be is that the only effect on an electron can have to the theory of gravity. Electrons are making gravity by moving. They're not affected by gravity in a sense. The individual electrons are not gravitational. They're causing the gravity that everything else is going to experience. But they themselves are not being affected by anything called gravity. They're just being pushed by bulldozers. There's no bulldozers, it's not bulldozers all the way down. There's no bulldozer theory that's, somehow changing their energy equation. They have real interactions with bulldozers. The rocks sit there and they say, I'm either being pushed by a bulldozer or I'm not. That's all there is from the rock's perspective. There's no gravity.
So far, this holds. But then you swap the positron with an electron and they repel, which is odd considering that this requires a wavelength shorter than the width of a particle, which is infinitely small. Which leads to the question, how can...
So again, this infinitely small particle thing, why is this even a realistic statement? How can somebody make these kind of statements? We know that light hits objects and it bounces off of something. It's not bouncing off things that are infinitely small. I mean, it just is too stupid. How can it hit something infinitely small? I mean, can't everybody just smell how much that stinks? This idea that electrons are so infinitesimally small. They can't be. They can't interact with forces if they're infinitesimally small. I mean, he's basically saying that would be the boulders. The boulders are infinitesimally small. Let's see, but we already know that the elements of the photon, the bulldozers, we already know that the bulldozer are much smaller than the electron. The real bulldozer. I mean, the real photon is really made out of little bulldozers. A row of them.
And you have a wavelength shorter than 0. Of course, you can get around this by considering the electron's wave function, but then there's...
Oh, silly talk. It's a wave function. So imagine if they, again, I'd be so great to be able to go back in time to Newton's day and Hooke and those people and throw this crap at them and see what they would say about this crap theory of a wave function.
Still is the issue as to why the wavelength of the first electron's ether field would change depending on whether the other particle is an electron or a positron.
Yeah, obviously charge is a significant thing to be dealt with. I mean, how does the same environment, right? I create one environment. That's the environment. And I put a proton in it, it goes this way. I put an electron in it, it goes that way. How do I explain that? Okay, and I don't think you can do it by saying, that by doing it with one force. I think you have to understand, well, there's obviously something they're inversely reacting to. One thing sees it as hot, the other thing sees it as cold. One thing sees red, the other thing sees blue. They have to be seeing something different.
Chalice was not privy to the knowledge of electrons and positrons, but the objections at the time were actually already simple enough and far simpler than those issues I've described. If matter creates these waves, then matter must always be imparting energy into the ether. Where does this energy come from?
The perpetual jellyfish. Where else? What do you think? Where does your energy come from? Virtual photon? That's a cop-out, buddy. No, newsflash. Virtual photon is not a very good placeholder for real energy. And magical bent space doesn't explain energy either.
James Clerk Maxwell pointed this out, and in fairness, James Chalice was very quick to admit that he hadn't really thought this one through. Now, there are many more ideas that people have entertained throughout history, but it is time to move on to the king of the mechanical explanations for gravity.
Right, the simplest, most obvious one. We know that the light bulb is a bunch of stuff coming out. It seems kind of obvious that gravity must be stuff going in. Inverse square law and all. So the simple thing to figure out is, why is more stuff going in than comes out? Why is that? Oh, that's right, because the bulldozers are slowed down pushing the boulders. That's all you need for an explanation. All finished now. We're done. All done. Gravity explained. Simple. Alright, so I guess we'll call this a video before he gets to the granddaddy, the Lesage theory. So, again, just pointing out, I mean, just how despicable. Deletes my comments, even though I didn't say anything nearly as rude as the crap he says. You know, it's just wrong. It's being a bad person. They're bad people. I mean, to imply that I haven't responded to this crap that they're posting, these stupid arguments. Yeah, I did respond to them. All right. Anyway, so till the next time and such, and so forth and whatnot. Maybe I'll make another video later today. We'll see how it goes. Yeah, I don't think there's anything that needs to be added. No, that's enough.